Hi, and welcome to this introduction to interpreting data. In this episode, we'll be talking about the concepts of central tendency and variability, which are very important when we're looking at data and trying to understand what it means. Scientists are always interested in what's going on in the natural world and in developing explanations for those phenomena. They do this by asking questions. So here's a whole variety of them. Looking at this picture, like why aren't there any deciduous trees near this lake? Or how has the introduction of fish into this lake affected the frogs? Is global warming affecting the glaciers? And so forth. There's thousands of different questions we could ask just looking at this scene. Scientists investigate those questions by collecting data. So here's a notebook that you can see. Somebody's written down a whole bunch of different figures and observations and data there. And then underneath that, you can see a spreadsheet. So oftentimes we'll take our data from an experiment and enter it into a spreadsheet or some other tool so that we can take a look at it and do things with it. But those are just numbers, and what we're really wondering is, well, what do those numbers mean? So we collect the data, but then we have to interpret it. So interpreting data just means making sense of the data. It means taking those numbers and trying to figure out what they tell us so that we can make claims and use the data as evidence to support those claims. You see an example here from PBS NewsHour. This is an article that says too many college grads or too few from February 21st, 2014. In this article, they're using some data from the Bureau of Labor Statistics, which is a government agency, and two different people are interpreting that data in different ways. One person thinks that we actually have too many people graduating from college and that it's leading to higher unemployment. The other person actually thinks we don't have enough people graduating from college and that will lead to a shortage of qualified applicants for a lot of different jobs that will be available. So in both cases, they're interpreting the data and coming to different conclusions. We make sense of data in different ways. One way that you're familiar with is by graphing data, and that is one thing we can do, but we also can use statistics to understand data. So it's not enough to just graph it, but we also have to do something with those numbers. That could be anything from finding an average to calculating standard error to something more complex like an ANOVA test to see if different categories of data are actually different or whether they're actually the same. So it can get fairly complex, but really it's all just an effort to make sense of the data. Now the two ideas we're going to focus on in this lesson are central tendency and variability. This is an example here, a bunch of different celebrities, and it shows their height. And you can see that we have a variety of heights there, going from Snooki on the far left at 4'9" to Hulk Hogan on the far right at 6'7", and then everyone in between. So we could look at these heights as data, and we could ask a question about how tall are the different celebrities. And we might conclude that on average, celebrities are about 5'6", so that's right in the middle there, around Justin Bieber. That would be a measure of central tendency, kind of an average. What's sort of a normal height for a celebrity? But we could also then consider the variability. So how spread out are these different heights? And in this case, we have quite a bit of variability, going from 4'9" to 6'7". So it's not enough to just say that the average height of celebrities is 5'6". We'd have to actually discuss how variable that data is. We use those interpretations then as evidence. So if we go back to our original example, we have all these different questions that we could ask. We would go out, collect some data, interpret the data, and then use that data as evidence, which would either support our ideas or would potentially refute our ideas, which means that it would suggest that our ideas are not correct and we would have to change our ideas or refine them in some way. So science is really a process of collecting this data and then interpreting the data to make claims. Our objectives in this lesson then are going to be to understand the difference between measures of central tendency and measures of variability in data sets, and to understand the importance of discussing measures of central tendency and variability in data interpretation. I hope you find this lesson useful.